All right, so now we've got two measures of central tendency, and then of course we have to decide which one to use. Do you use the mean or the median? If there's a choice, well, when do you use the one and when do you use the other? For example, if we look at the same variables we just looked at, the same 10 variables we just looked at, if we look at age, we see that the mean, we said it was about 50. The median is also roughly the same thing. It's a little, it's almost a year less. By the way, this is what, this is the 50th centile, and that's how you get it from Stata. You get it from the detail command. Sex, now this is, remember this was 0, 1 variable. Well, look at what happens to a 0, 1 variable with the median. It just tells you which of the, in this case, the value 1 or the value 2 is more popular. And we said that the value 2 was 54%. So the mean is not as informative, it's not as nuanced as the mean is in the case of dichotomous variables. Systolic, it's pretty much the same, it's close, it's off by 4, the difference is about 4. The diastolic, blood pressure, pretty much the same. The current smokers, the same as sex. It's not very informative. It just tells you that whichever one has got more than 50%. The cigarettes per day. Now, this one, look at this. This one is 0. Why is that? Very similar kind of argument, because more than half the people are non-smokers. So more than half are at 0 cigarettes per day. So once again, in this, for a different reason, slightly different reason, this is not very informative, because it just tells you that more than 50% are at 0. And once again, we'll look at this carefully. BMI, very, very similar, 25.64. So the mean and the median. Now, this is another case of dichotomous variables. The heart rate, same thing. So we seem to come out of this, from these 10 variables, thinking that for dichotomous variables, or one where there's a big lump, big bunch at one value, namely 0, the median is not very informative. It's not sensitive enough. So even if the mean may be too sensitive, the median is not sensitive enough. Now, let's take a look at our number of cigarettes smoked per day. And there it is. There is a bar chart, if you will, of the variable in question. Now, how are you going to describe this variable with a single number to describe the center of this? It's not very easy to do, and I dare say it wouldn't be very informative even if you could do it. But an interesting thing is, why is this so big? And in order to answer that question, this one we know because there's just a bunch of people that don't smoke. But what about the second one here? It's interesting to take a look at the variables. I've done them here, but just tabulate this variable. And there it is. It's 4,402, and more than 50% are at 0, so that explains the median. But run down here and take a look and see there's a phenomenon here that is at play. Namely, look at this number here. It's very big. Look at this number, very, very big. Here's another very, very big. So why are those numbers very big? Here's another one very big. Because you used to buy cigarettes in packs, and there are 20 cigarettes in a pack. And so what are these people telling you? Oh, that roughly they'd smoke, 1 pack a day. These, 2 packs a day. Maybe a little bit more than 2 packs a day. Here are the ones where the packet would last maybe 2 days. Why the 9 is there, I have no idea. No idea why the 9. The 5 because it's a nice round number. And you see this very, very often in data, and you should be careful of this. And that is that people like to round off to the closest round number. You know, so 5, 10, 15, 20. Here 20 is really popular because, as I said, there was 20 cigarettes in a pack. But whenever you ask people to give you numbers, how many carrots did you eat yesterday? That kind of questionnaire, you're going to see this phenomenon, that there are numbers around which they bunch up. So, getting back to the original question, mean or median? And, you know, if the computer's going to be doing all the work, let it do all the work. Use them both by all means. When does the one perform better than the other? Well, when you have continuous data, then the mean performs best when we have a symmetric distribution with thin tails. So something like this with thin tails, right? We don't want fat tails. We don't want this going off like this, fat tails. We want thin tails and roughly symmetric. If, on the other hand, the distribution is skewed like this, that means you start off with something like this and then pull this one out. So if it's skewed like that, then advice is to use the median. And this very often happens with survival data. How long do people live? So when you have survival data, so how long do people survive? How long do they live? That very often looks like this, and as a result, we very often use the median. Now, just a little tip. Remember, the mean follows the tail. So we call this the tail. So this is the tail. The part that gets pulled out, that's the tail. And the mean follows the tail. So in this case, the median might be here. So this might be the median, and the mean might be here. So the mean might be out there. So the mean follows the tail. And we're seeing this. Let's go back to our variables. For example, with the systolic, the mean is bigger than the median. With the diastolic, the mean is bigger than the median. And that could be because we have a few large values on the right-hand side. This one, the mean was much bigger than the median because we had the cigarettes per day. We had a lot of people out there smoking a bunch of cigarettes per day. The heart rate, the mean is bigger, and as is the glucose value. Remember, we have these diabetics in the group. There may only be about 2.5% of them, but they would pull the right tail up, and that would explain why we have this difference between the mean and the median.